The Doppler effect is an apparent shift in the frequency of a wave relative to an observer. So a lot of times we're going to be talking about how a wave is going to be affected because the source of the wave is in motion. Now the Doppler effect is used for Doppler radar, and most of you have heard of Doppler radar, where Doppler radar actually is sending out these different radio waves, and with the different radio waves, they're being reflected off of different objects, and the reflection is transmitted back to the radar, and that's how you're able to detect the rain or storms or snow or even movement of birds and insects you can actually get off of the Doppler radar. That's really more of an electromagnetic wave that we're talking about, and in this course we're sticking specifically to mechanical waves. So I want to talk about how the Doppler effect applies to sound, since sound is one of our biggest mechanical waves that we look at. Just to get you started, before we actually look at how it works with sound, I just want to give you a quick example. And the example is if you were to take just your finger and if you were to put it into a bucket of water or a puddle or a pond. Now, when you touch the water, basically what happens is you send out these pulses and these waves, and you can see that the pulses and the waves are going to move out in these nice concentric circles. So we have these concentric circles where the wave's moving out, and it's moving at a certain speed. So the spacing between the circles is going to be constant. In fact, the displacement is going to be equal. So if you look in between the different parts of the wave, it's going to be equal. Now, if you were to keep doing this, what would happen is you'd keep sending out these concentric circles. So if you keep touching the water over and over and over, if you touch it at a steady rate, that's what's going to happen. You're going to have these concentric circles just keep moving out and out and out and out and out. You'd see something like this. Now, let's just say, for just an example, I'm going to draw this a little bit larger. If you were to take your finger and if you were to press, basically touch the water, let's just assume that after 1 second, this is where the wave is going to be. And let's just assume that after another second, this is where the wave is. But we also have a new wave that started there if you were to touch water every second. And let's just say after 3 seconds, that's what we'd have. And then the original wave would be, not the original, the new wave would be right there. Then we'd have a third wave created over there. And then after 4 seconds, same thing. So we'd have another wave, and then we'd have another wave here, and then another wave here, and then another wave here. And hopefully you get the point. You're going to see these concentric circles form, and every second you're going to see a new circle, and the previous circle would have moved out a set distance away from where it was. Now, what if we actually moved where our finger actually was? So let's just say that we're moving to the right. So if we create our dot right there, after the first second, our original wave is going to be about like so. But let's just say that we're moving a little bit to the right. So the next circle we're going to create is right there. Well, after 1 second, what's going to happen is this first circle is still going to be concentric to where it was originally, but we're going to have a new circle now that's actually going to be more like that. And then what happens is after that, if we move over again, we're going to have our first circle still concentric. We're going to have our second circle, it's still concentric, except now it's shifted over a little bit. And then our third circle is going to be about right here. Now, it's probably hard to see with this, but what happens is you get this pattern where if this is let me kind of show you here. If this is our circular pattern, it looks something like this, where the circles are concentric based off the original spot, but the source of the next circle keeps shifting over and over and over and over to the right. And that's because the source of the sound is actually moving to the right. So you keep producing these new circles, these new waves, in different spots that shifted over to the right. So it looks something like this. Well, what that means is that if you're a person, and let's just say this is a sound wave, if you're standing right here, what you're going to hear is the wave that's coming towards you. If you're standing over here, you're going to hear the wave that's moving away from you. And if you notice, there's a difference between these two waves. The wave over here on the right, for the person that it's moving towards, that's more compressed. So we have a smaller wavelength, so we have a higher frequency on that side of our wave. On the back side of it, though, you have a lower frequency. And the lower frequency is because we have a longer wavelength, a greater wavelength between the different circles. So this is really what the Doppler effect is. When you have the source of this sound that's moving, you're going to create a higher frequency sound ahead of the source. You're going to create a lower frequency sound behind the source. And you can probably think about this in some real life examples. If you have an ambulance, as the ambulance is moving towards you, it has a pretty high frequency sound. As it passes you, you hear that, you'll hear the sound, the pitch of the sound go down, and that's because now you're hearing the lower frequency behind it. Same thing with the train. Same thing with anything that's really moving towards you, and as it passes you, the frequency of the sound that's created is going to go down. And that's because of the shift in the circles that's being created, the shift in the waves will create different wavelengths and different frequencies. So hopefully that helps you understand what the Doppler effect truly is and why you actually hear some of those different pitch sounds when things move by you.